it kind of started collecting Volkswagens, building Volkswagens back in '79. I've got my very first car I ever built. I'm sitting over here on the Swift. It's a Sandman. And I built the engine in that car, like I said, the '79. It's been apart back together a couple of different times for various reasons. 6 months into after it being built brand new, took a little Sahara and I lost an air cleaner off of it. Of course, you know what happens when you lose an air cleaner and a little Sahara, you fill that engine full of sand. So we pulled it back into the campground, threw a new set of jugs on it, and I finished the weekend right there on the spot. So anyway, just a little history in that aspect. I've been involved with air-cooled Volkswagen since about '79. I've mechanic for a living since I was 16 years old, which is about 81, 82. Present, I've kind of got a little bit different situation when it comes to mechanics now. I actually turn wrenches for a living. I kind of do, but I don't. I work on high pressure compression equipment now in various ways and types. Still do lots of Volkswagen work. Probably, I've seen the last 7 to 12 years we've collected probably, I think we've got over 20 Volkswagens. And I always tell people, you either have to have a whole lot of money, or be really stupid and a whole lot of money, or or be a glutton for punishment, because none of them stay running all the time. I constantly have to keep her tweak on all of our cars that we have. And as long as Mama's bus runs, I'm good. Doesn't matter about anything else. As long as Mama's bus runs, it's good. So we've got a lot of vehicles. I've done everything from partial restorations, mechanical restorations, complete restorations, engine builds, transaxles, transaxle builds, everything in between. I do a lot of electrical work. So my experience is I've had a lot of practical experience with work on these cars. I'm going to cover some stuff on these engines today. We're not going to build a complete engine. So I just want you guys to realize that. What I try to do, 2 years ago we had the class, we had about 60 days, about probably 40 people, and about every 5 to 10 minutes I'd get a question. So I'd stop and try to answer the question. We never got the engine built. The reason for that is I try to answer all the questions you guys have. This year we decided that we were going to pass out this stuff so you have it. You write questions down. I will cover a segment. First segment we'll cover today is the engine cases. We'll go over what the situation is with these engine cases, what types of engine cases, some of the things like that. I'll probably go ahead and build crankshafts so you guys can kind of see what's going on there as well. There's some very specific things about these engines. Years ago, you could buy a kit, put the engine together, and it's perfect. Not anymore. It's just not how it works. You get into some of the more exotic stuff. I've got a stroker motor sitting here on the stand. It's partially built. There's just a lot of things you have to do when you assemble these engines. And to do a stock 1600, this is actually going to be a stock 1600 here. I would imagine, I'm hoping, maybe, I won't have to do any machine work on it. But 9 times out of 10, you end up machining cylinders or you machine the cases, especially these aftermarket aluminum cases. The cases are machine dry, but no two of them from the center line of the crankshaft out to where the cylinders sit against the case are exact, right in it. And what you get into, it's not a bad thing, but what you get into, deck height is extremely important in these engines. It'll make your break. And if you set one of them up, you got 12 to 1 compression, you don't know it, and you go put a plain junky gas in it, it's not going to run for you. It's just not. I just got through doing a $12,000 performance engine for a real good friend of mine. He's going to run nothing to VP racing in this fall. That's all he's going to run. But he has to, because that compression ratio is going to warn it. I love to build these engines. I like to keep them around 7.5, 8% compression, maybe 8.5. That's it. I don't like to go much further than that unless somebody completely understands they're going to have to run race gas in the engine because they do not perform the work as well on just plain 87 octane pump gas. Everything I run in mine, we run unleaded. I do not run any ethanol fuel in any of my boats. Never, never, ever. A lot of people live in places that's all they can get. So it's one of those situations. It eats fuel lines up, all that kind of stuff. So we'll go ahead and get started. Has everybody got a pad and pencil? I think we got some more people coming in, so we'll go ahead. We got some more coming in, so I'll chat some more. You guys got a chair? No? Okay. There's one up here. We might be able to scrounge up another chair, maybe. I don't know. We might be able to do it. But again, what I want to do is instead of taking a bunch of, yeah, sure, absolutely. Take a bunch of questions and stuff. I don't want to stop, in the middle of all of it. Let's go ahead and try to cover what we can. Again, we won't be completely assembling an engine today. It's just a tough deal to do. I usually spend 8 to 12 hours building stock, and that's me out here not even taking breaks. It's just me doing my thing. So, but I think I'll give you enough information to where anybody that would like to come back, lives locally. I'm building one of these engines. Build one or two, one a week. So if you want to come back and actually see one completely from start to finish, you've got a few days. You want to come out here and spend a few days with me out here in the shop, help me build one, we can do that. There are a lot of things to have to cover, and I think it's very important that everybody understands all those steps and processes. So we'll go ahead and get started. I'm not going to have everybody introduce themselves for this stuff. It takes 20, 30 minutes to do that. But we'll probably get to know each other a little better as we go along in the class. I want to start with these engine cases. And basically, as we were talking about before, I've got this engine case that's on the stands, an Autolinia. It's an aluminum case. They are 22 pounds heavier than a magnesium case. They're built thicker. Aluminum is a little bit weaker material, so it has to be heavier made in order to do the same thing. This is a dual relief case. Earlier Volkswagens have single relief. The difference between the two is you have one piston versus two. I can go into all the mechanics of that portion of it too as well. Other than what that amounts to is it just gives you another area and ability to have a second relief in that case versus one. They went to the dual relief because it worked better, created less problems with blowing, busting coolers, oil coolers and stuff. Also, it was a different setup on the cooling system as well, because that is the oil in these engines. That's the cooling system that cools these engines. So basically, the differences in these cases. I've got a mag case over here too that's been in process to be worked. This is an actual magnesium case, and as you can see, it's not super heavy. It's not light, but it's not super heavy. That thing there weighs over 42 pounds. It's heavy. So, and this is just a standard magnesium case, dual relief. When I talk about dual relief, there's two holes here. That's for both your pistons. You have a piston with a spring that goes in each one of these holes, and that regulates the oil pressure in the system, whether it goes through or bypasses the cooler until it comes up. So, just trying to think of anything else. A lot of guys, you can rebuild your case. You can use your case as long as the bearing journals and the saddles are not beat out. And when I mean beat out, when it's been ran long enough, the case will work. And they put the split case, they'll move around. And they'll move around enough sometimes that the case to the point to get really do a lot of machine work. You can line bore these out. I don't normally, when I build engines for people, I usually try to go with a brand new case, especially if they're doing a performance build, or they just want an engine that's going to be, they're going to keep the car for a real long time. I've had these cases, line board them out to over 100,000. It's oversized. We got a friend of mine that drag raced for years. He had an OMAG case. He line boarded out to 100,000. He had two separate case halves, not even from the same engine. And I don't know how many runs, how many quarter-mile runs he had on the engine. It's still, I mean, it leaked a little bit of oil, but I mean, other than that, he didn't have any problems. So I don't normally recommend line boring these cases and trying to build them. One of the things you get into with these two is if somebody's going to sell you a used case. They're going to build you an engine. They're going to sell you a case that's used and the machine work's been done. In order to properly set one of these cases up and do it right, all these holes here, these are for plugs. These are oil galley plugs. All these have to be taken out, and all of those entirely need to be cleaned out, vatted, and wire brushed. Because if you have one speck of junk that stays in that case, and you put that brand new engine together, it might happen in a week, it might happen in a month, more like it's going to happen pretty quick. Spin a bearing, tear a bearing up, have an oil pressure issue, then you got problems. And here you have, $6,500 worth of parts that you can throw part of in the trash because somebody didn't clean that case up. So just the machine work. That case savers, that's another thing on the cases. A lot of times factory, they came out with 10mm studs. Go back with 8s. You do case savers, that's another machine process you do put these case savers in to strengthen the case and the threads on the case, keep it from pulling out. Same thing over here. All the galleys have been driven. Now these two don't, because this is a little pickup tube and this is just a standard spot. Those two are accessible from inside the case. The rest of these are not. But all of these points here that have, they're supposed to be plugs, and those have to be machined, and you tap and machine these. You tap these, and then you put plugs in once you clean the case. So again, pretty labor intensive to use a used case. By the time I take the time to take it over there on the mill, clean these, vat them, do the operations necessary to use a used case, I've got just about as much labor as you would have if I just sold you a brand new case. We're starting off brand new. I don't have to worry about any dirt or anything in that case. So, not that you can't do it, you can. I've got the equipment to do it with. I've actually got probably half a dozen cases that are various levels of being lined with, ones at 20,000, ones at 60. They're used cases, but they're ready to go. I just don't sell them to customers. I like put them in one of my own cars, but if I'm going to warranty an engine, I like to do brand new cases. So, but that's that. And with that being said, we'll go ahead and move over to this case. And this is an aluminum case. This is just a standard aluminum case. Pretty much standard. The internals of this case is identical to that magnesium case. That part of the case is identical. The exterior of the case is different in some ways. These cases, same thing. Dual relief. I don't have it. The relief valves are on this side of the case. Dual relief case as well. This is a standard. That's something else that I'd like to cover too. These cases depended upon, and it creates other problems for other things, but these cases, some of these cases are sand seal cases. People talk about a sand seal. It's hit and miss. If you seal one of these up with a sand seal, then you better open that case up and let it breathe, because this is designed to get air through. And that's why Volkswagen never put a seal up here. They have a slinger that sits in this groove that keeps the oil from getting past that. And if it does, it gets on the pulley, and there's little grooves on the pulley that send it back to the case as it runs. It spins it back off. If you seal the nose of this case, you better make sure the rest of that case is open. And what I mean by that is you want to put a crankcase ventilation system on. If you're turning a big motor and run a hot motor, you better have a crankcase ventilation system on the engine. I don't care what you do, you better have it. If it doesn't, you're going to push seals out, you're going to push gas, you're going to have oil leaks. It's just all kinds of things will happen. And it's very important. There's nothing wrong with sand seal. We had a point there, all I could get was aluminum cases that were designed for sand seals. So I had to put sand seals in them to make them work, because this is poured out bigger in order to take the sand seal. So you can't use a stock pulley on it, have it sealed, sling oil out of the nose of the case. But again, crankcase ventilation is pretty important as well. So, with that being said, we'll move on to bearings. You get my glasses on here. Okay, 8mm studs, 10mm studs. The reason, like I say, the other thing you get into with a lot of guys will come to me. I've got a case right now that I'm machining for somebody, and they want 10mm studs because they're going to build a turbo motor. I'm not building the engine; somebody else is. I got to have 10mm studs. I said, that's fine. I said, now you understand that when you start putting this engine together, you're going to have to machine your cylinders and jugs. What do you mean? I said, 10mm studs on 94mm jugs, they don't work. You have to open the holes up even bigger. Cut those jugs to fit those to where the studs will fit. He's like, oh, well, I didn't do that. Well, I'm just telling you. Once you get to that point, you're gonna have to do that. So you're gonna spend who knows how long just drilling those jugs out. And he said, I really don't know a way to drill those jugs out. I said, well, you think about that. Well, I've always been told that I need 10mm studs. I said, who told you? Well, blah, 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 blah. Well, these chromoly studs, I've built a ton of these engines. Hot motors, I've built some 12-to-1 engines, never had a stud pull on. So, and that's with an 8mm stud versus a 10. And the 8, between the 8 and the 10s, I don't think, got those rates. These, on this engine here, are all 8mm studs with 8mm case. You can put 10s in them, but again, if you're going with any kind of large cylinder, big bore cylinders, you're going to have to drill those holes. The holes here where these studs right against the cylinders, that all has to be opened up and clearance. So that's a problem. Unless you have the right equipment, the right stuff, you get out there with a die grinder and probably do it. Who's to say how long it's going to take to get that done? So, but anyway, so case studs, cases. Let's go ahead and talk about bearings. Case savers. Oh, another thing, very important. Talked about the relief valves, the piston, the relief pistons in these cases. 9 times out of 10, on a new case, you put those in, and again, it takes a special tool. That's a special tool to stick those in and out. I'm going to cover a lot of special tools today. I got a whole toolbox full of special tools just to build these engines. Nothing that you can't get anywhere, you can't buy. This is necessary and mandatory and important. I spend 30 minutes fitting relief pistons to a case. I spend at least 30 minutes making sure they work. Because if they stick, you're going to blow the top of your cooler right off the end. First time you fire it up. And then again, if you don't catch it, you're going down the highway and one of them sticks. You're gonna probably roast your motor. You're gonna burn the motor up. So that's another important thing that a lot of people don't talk about and cover. But that's certainly something I've been known to spend 30 minutes fitting pistons, just making sure the pistons slide in and out and feel good. The emery cloth on them, whatever it takes. And that's brand new. That could be a brand new piston. So it's not so much a situation that it's a perfect seal. It's not, because it's metal to aluminum is what it is. There is no rings on it. It's just kind of a resistance fit is what it is. But they should slide in and out. And honestly, they should slide out pretty easily. You turn the case upside down, they should almost fall out within reason. I mean, you put them on the end of this and work them in and out, you can feel them. If they move pretty good, a lot of the cases are okay. Sometimes they're not. Sometimes I got to wire brush the doors. In a new case, I have to wire brush the doors and emery cloth the pistons. So, and I think,
Hey, Mark,
yeah.
can we get everybody to kind of scoot together a little bit and let some of these people get away from the door?
Yeah, absolutely, guys. If you would, please scoot you up a little bit. Get to know your neighbor a little better. Okay. Perfect. And anybody that doesn't have a notepad and a piece of paper or pen, hold your hand up, and we'll get you taken care of right quick. Oh, you did. How many we got, guys? Just stack up. Yeah, all right, thanks, Daniel. This is that little piston I was talking about. It's got a hole into it. See that? And now, what's interesting is the aftermarket pistons have a little bit bigger opening on the end there than the stock pistons. So this tool doesn't completely fit it. The little, not much resistance there, so you have to really kind of crank the tool down to get it to hold the piston. And the thing is, with that, and I'll go ahead and do it right quick just so you can see. Yeah, it's on there. But that's what that amounts to. What's important about this, like I say again, if that sticks, it's going to blow your cooler up, or it's going to do all kinds of crazy stuff to you. It's important that moves in and out of the case fairly freely. If it doesn't, you're going to create issues. That's my problem. I got an engine sitting on there right now that somebody else built. A really good friend of mine contacted me and said, "Mark, I put this thing in my bus. It's pegging the oil pressure gauge. I don't even know how much oil pressure it's got. Over 120." And I said, "Okay." So well, that sounds like my bottle when it's cold. But anyway, it's in my bottle do about 100 pounds of oil pressure when it's cold. So you have to just kind of let it warm up a little bit before you get crazy with it. You go blow cooler on it. And that's because it's got a big pump on it. That doesn't have anything to do with the problem with the engine. And I run thick oil in it. But yeah, it's important that these things slide in and out of the case correctly. And as you can see how that is? You guys can see that. If you watch on the screen, they can probably, but you can kind of see. Let me flip that over so you guys can see that. Okay. See that? That goes in there pretty nicely, you know. And with oil on it, it actually slides in and out of it. This one won't need anything done to it. So, and it's another thing people ask me about. Well, what kind of lubricant do you use to put your engines together? Do you use that $6,000 lubricant? This, that, and the other? No, that there is 2050 Valvoline VR1 with zinc. That's all I use to assemble these engines. Now I do use a cam paste. Something's important. It's a flat lifter cam. It's extremely important you use the correct stuff. All cam manufacturers send a specific lubricant they want you to put on their cam and lifters. It's very important to use it. The more you use of it, the better off you are. So, and when you first fire one of these engines up, I don't idle them. They run at either 2,000, 2,500 RPM for at least 15 to 20 minutes before I shut them down. That allows the cam and the lifters to run. In that first few minutes, you're monitoring oil pressure and temperatures. You're going to see if something's going wrong. You're going to know. So at that RPM, you need to watch it closely. If your oil pressure goes out of sight and you've got something else going on, you need to shut it down and start looking for a problem. But it is very important to do your cam break-in and stuff on these engines. It just depends. Most manufacturers say 2,000, some say 2,500, so it's kind of in between. I just put a little lubricant on that piston. And if I had it sitting straight up, it probably would fall in there. See how that works? That's what you want. I mean, that's really what you want. If that goes in there and it's stiff, you got problems. You're going to have an issue. And the minute you fire that engine up, you're going to have that problem. So it's going to be an issue. But again, both those holes. And I've had to take these brand new cases and run a wire brush through them. And I prefer a stainless steel brush on aluminum. Just my thing. It's something I like to be able to utilize. I don't use any other kind of brush on them. I use a stainless steel brush, and it doesn't have to be crazy. You just swab it out a little bit, and then of course sometimes, like I say, you have to emery cloth the pistons and use some crocus cloth or emery cloth. So that's the piston fit on that. That's the relief piston setup. Trying to think if there was anything else. I've made myself some notes because oversized bearings. I don't have any oversized bearings sitting out here, but they do make the oversizes in 20, 40, 60, 80, and in some special applications you get 100,000 oversized. These are a standard bearing. standard thickness. And when we talk about oversized bearings, it's two ways: be oversized on the outside, oversized on the inside if you turn the crankshaft. So I don't turn crankshafts. Costs about $175 to have a crankshaft turn. I can buy a brand new crankshaft for a little more money and have a brand new crankshaft. So nothing wrong with doing that. You're just adding to that machining process. Oversized bearings are a little more expensive than stock bearings. These bearings, these are standard bearings. I'm not going to get into the sizes of the bearings because of just confusion. There's a whole chart. One of the things about these bearings too, Volkswagen bearings and cases are designed, they have dowel pins. That's what holds the bearings in place in the case to keep them from spinning. Okay. What you have to remember when you're building one of these engines, and as you assemble one of these crankshafts, there's captured bearings on this crankshaft. So if you get on there, you get all your bearings assembled, and you've got these front two bearings are captured. And when I mean captured, you put these bearings on, then you heat a timing gear or crankshaft gear up, and you slide that onto the crankshaft. It cools and it locks down when that bearing's on. The only way you're gonna get it back off is to pull that gear back on. That's a puller to pull the gear. So, and if you get that bearing backwards, it's not even going in the case. It will go in the case. It will go in the case. And you'll know. You'll get it all put together, and man, you'll just be so happy and excited about how you're just doing such a great job on this engine. You'll have it all torqued, and you'll be ready to grab it and turn it. Crankshaft. You're like, why in the hell did that happen? It's because the bearings are put in backwards. And when I say backwards, the thing you have to remember, and that's the easiest thing for me to remember, is you've got your flywheel end of the crankshaft. That's considered the front of the engine. Okay, this is considered the back. This is the pulley end of the engine. That's the flywheel end of the engine. These dowel pin holes, these recesses in these bearings are offset. You can see it's not centered. So if it's not centered, it probably goes on there a specific way. If it's centered, it wouldn't matter. Maybe. That's something else you can get into too. But this is offset. So you always put the offset towards the flywheel. So when you assemble your crankshaft, all these bearings that are captured, that bearing dowel hole is going to be the closest it's going to go towards the flywheel side. Okay. And I'll explain it. We'll flip this over. I'm going to put some dowel pins. It's something else I do too with these bearings before I ever put them on the crankshaft. It's very important. It makes it easy. I haven't pinched a set of bearings in probably 10, 12 engine builds, but I've pinched bearings before and had to pull one apart. I got in a hurry, had one slip just a little bit, pinched the bearing, and the crankshaft won't turn. It won't turn. They lock it right now. I've had people bring me engines. So I had a good buddy of mine help me build this, and now it won't turn over, and I'm like, yeah, it's got the bearings in it backwards, or they pinched the bearing. And all it takes is just a tiny bit of pinch, and that's it. It'll lock the crankshaft down. And it won't move. You put a cheater pump underneath it. It's not gonna move. So that's another very important thing about these bearings is to know the difference in how they go. And this is the front bearing. This is the bearing closest to the pulley side. Then you do have a split bearing that goes in the middle of the case. And again, if you can see this, I'm going to try to see if I can show this, but you can see that this is definitely offset. That pin, that dowel pin hole is offset on both bearing halves. Okay, and that's the split bearing that goes in the center. That's the center bearing in the case. One will go in that half, one will go in this half, and they're ambidextrous. These two bearings, there's no difference between the two. They're identical bearings in the sense that they'll go in the case. They actually offset when they go in the case. The holes will be opposite. A hole on this side, a hole on that side. The same bearings. Awesome. So that's the only one that's kind of the easy bearing. I say easy, it's not hard, but and then this is your front bearing that's captured. This is the one I was telling you about. It's offset hole. Hole's offset. One side of the bearing. You can flip it on there. It'll go on. It doesn't matter. It'll go on the crankshaft whichever way you want to put it on. It's just it won't go in the case It'll go in the case, and you literally, it'll mash that dowel pin into the other side of that bearing. And the minute it does that, slot your crankshaft up. So, same thing with this bearing. You just have to remember that offset goes towards the front or the flywheel end of the engine. Always, always. And this is the front bearing that goes right here in this first journal. The front big bearing. And again, you always just remember you're assembling here. So what you want to remember is just make sure all your offsets are towards the back of the flywheel into the crankshaft. So that's where that one goes. And again, I'm gonna show you something on these bearings too that I always do. I have forever. And then here's your thrust bearing. It's a beefy devil. It's got all kinds of cool stuff. It's got these flanges and all that. Same thing. It's got an offset as well. These flanges is where that's your thrust surface for your crankshaft. That's something else that I'm going to try to do today because I think it's really important that you guys see that. Setting in play up on one of these engines. That's extremely important. It's just like that. Right? It's one of those things. If that's not right, that's going to make a difference on whether your engine's going to run for a very long time or if it's going to run for a very short time. Factory on the end play of these engines is 3 to 6 thousandths. There's some variables that go into that. If I'm building a hot rod motor that's going to run $8,000 all the time, I sometimes tighten them up just a little bit. I'll get more close to 3 thousandths. It just depends. It really is when I build the engine, kind of the preference that I feel like I want to set it at. I like to try to set them at 4. It's kind of in between 4 thousandths. There's some specific tools and equipment you have to have in order to do that. So you can't do it with a pair of pliers and screwdriver. It just don't work. You do use some screwdrivers to check your end play, but yeah, you can't do this without specialty tools. I mean, there's no magic. This is one of those things. Setting in play is something that they can send you some shims in the kit, and unless they have actually assembled that flywheel in that kit with that crankshaft with that bearing, that's one of the things that's the black magic. Some of the black magic you got to do yourself. And there's one drawer over there that's got 8 different size shim thicknesses. And sometimes here lately, I've been grabbing 3, throwing them on there. Boom, I'm on the money. Been the last 4 engines, it's been perfect. I had to take the flywheel back off. Previous to that, I might have to take the flywheel off 5 times. So, but I like to try to get them around 4,000. So if they're a little tight, I like to get them back up towards the looser end of things, not super loose. But again, that's very important with these and setting these engines up. Make them run and be, have longevity. Something else we're going to cover on that. We'll flip this case back up. Okay. Again, these bearing saddles, you can see the holes here. We've got holes here in each one of these saddles. There's your small bearing, which goes up front here. There's a hole for a dowel pin. And when these go in the case, I'm gonna go ahead and put dowel pins in this case and show you about putting these bearings in. I got to come up with some dowel pins. All right, it takes 5 dowel pins. These engines take 5 dowel pins. I've got 4 here, so we'll do this in the case. This side of the case as well. That split bearing, it's got a dowel pin. This one only has the 1 dowel pin that goes in this side of the case. So you have to remember that, not forget it. There's 5 dowel pins in this engine. 1 goes in this side of the case. The rest of the other 4 go in that side of the case. And these dowel pins, these gals can be heartbreakers. You get them in there and you pinch a set of bearings and you're like, oh man. And you wouldn't think it, but these little cuties, they can do it. They're not very big, they're pretty small. But and you've got one that goes here in the front. And what happens, we're talking about used cases. A lot of times, what happens with these cases is the used cases end up, the dowel pins can be worn, the case can be worn enough that the dowel pins walk. That can be repaired. It's just a lot more work, it's a lot more machine work. I've repaired them. I don't particularly care to. Not especially. The guy's got a hot rod engine with a high lift cam, and he said, "Man, I got to repair this case. And like your dowel pin holes are walling out." So, and they're like, "Oh, I want to keep my case." And, well, okay, but and they should go in there fairly easy. Some of these cases, they can be a little persnickety. That's a neat little hammer. A little story about it. In my trials and tribulations of being a professional mechanic, I did a lot of big work over the road truck diesel engine repairs, and that's actually a wrist pin out of an AP71 Detroit diesel that I built. We love to get these because it makes a great hammer. Neat little hammer, and it's really soft brass, so you don't tear anything up when you're using it. That's the story about that little hammer. And I actually remember the engine to this day very well because 2 weeks after it was built, it was a yard truck. 2 weeks after it was built, one of the yard guys got out there and let it run away with itself. So, and it was a two-stroke diesel. And Detroit's were notorious for that. So, anyway, okay. So we've got the bearings. We've got the bearing dowel pins in here, and that's something that I'm going to cover here. I mark these bearings, and it's not because I'm stupid or I'm not intelligent. I don't like to make mistakes, and I want to make sure I've got them right. And when you'll see when you assemble all this stuff on the crankshaft, you're holding on to rods. You got 4 dowel pins that you're having to wiggle around and move bearings around. If you don't mark these bearings, you're going to be there a half a day trying to get them all to line up, drop into the dowel pins, and you're going like, "Oh, what in the world?" What I do is I scribe the back of these bearings with a pick, and I also I get a black Sharpie and run across the back, so then I can see where that bearing's supposed to sit when I start to take it down to the case. And it's usually this bearing right here is the one that gives you the most grief because it moves around the most, and it's a lot harder to get centered in there. So that's something I always do. Again, when you're marking these, you got the case prepped, you got your dowel pins in, you take your bearing, and this is the back bearing, this is your thrust bearing. You're going to set it in the case. Okay, and you see how I had to squish that in there? And then when you pull it out, it should have somewhat of a resistance fit. See that? Okay. All right. So what then I do once I get those bearings pressed into the case, and it doesn't matter what color I'm and I should have it. Yeah, right here. Okay. Okay. So what you want to do once you get that bearing in the case, and you're not going to hurt the bearing. The back side of that bearing, if that one scratch on the back side of that bearing is going to create a problem, you got more problems than that. And you don't have to go crazy with it. You just run that pick across there, just like that. And then I always go ahead and run me a magic marker. run me a line across it with magic marker, both sides. Because if something happens and I handle the bearing enough and I knock the magic marker off of it, I've still got my scratched line. So, and again, that just saves you a lot of grief and trouble. See how that works? Or everybody see that? I don't know if I'm standing in the right place for everybody to see it, but everybody see that? Does everybody see that? See the scratch mark in the bearing and my magic marker line? And you can see where it's set down in there perfectly on the dowel pin. So there's that. So I'll just go ahead and set that back in there. And then whenever you, like I say, when you get this stuff put together on a crankshaft, you'll see what I'm talking about. Because you got 4 bearings you're having to molest and mess with and work with and try to get situated in order to get that crankshaft to drop in. And you want to make sure they're right, because you pinch that case together on it. The minute you torque it down, it's going to lock the crankshaft up and you've got a problem. And at a minimum, you're going to have to put new bearings in. So, which is not a minimum, because you're going to take the entire crankshaft back apart again, put it all back together, and then start the process again. So half shells, of course, the half shell you don't have to mark it, because it just goes in the case. Right there. And the next bearing you got is the captured bearing that I was telling you about. Always mark it too. So we put it down in the case. A little scratch mark across it. And again, you're not trying to dig the cyan with that pick. You're just putting a scratch mark on it. And everybody says, well, what's the reason if you're going to mark it with a magic marker? Well, I've not marked them with a magic marker and scratched them. Or I marked them with a magic marker and didn't scratch them, then I handle the bearings 3 or 4 times, and then my magic marker's gone, and I'm like, here we are. I should have scratched them. So that one's in, same thing. You can see how that mark's made. And sometimes too, you can even, if you even want to go one step further, and it doesn't hurt anything, you put your line on the top of that, so you know that that's straight up and down. You can do that too. Magic marker doesn't hurt the bearings. And then of course, same thing with the front bearing. You do the same thing. And this is the one that's the frustrating one. It's usually the worst one to get in the case. See, you really can't mark this side because there's really not anything there to mark, so you have to use your magic marker on it. And again, the magic marker is not going to hurt the engine. It doesn't have any effect on the engine whatsoever. So there you go. That's how that works. Okay. So now that we've got our bearings marked, we've got that stuff done, we can look at pulling the crankshaft. So, I think they're planning on having everybody, because it's going to be really hot today. I think we're planning on breaking about 11 to get you guys in and start getting everybody to eat. Break up the monotony, try to get everybody through, because we've got quite a few people here today. But we're going to probably break at about 11 o'clock, have lunch, take about an hour to eat lunch, and get back on this. I will, once we get through, I'm going to go ahead and build this crankshaft so you guys can see that go on. I'm going to talk about rods. I'm going to do that before we start building the crankshaft, because rods are pretty, it's a whole nother, again, I'm going to flood you with information. But I think it's important that you understand these things, because if somebody else builds your engine, you know what to ask them. You can say this, that, and the other. Is this been done this way, or this been done that way? And then you know whether the person that's building your engine for you truly knows what they're doing, and they've done. And there's a lot of great engine builders out there. I'm not knocking anybody. Everybody makes mistakes. You build enough of them, you're going to have some problems come up. It's nature of the beast. But a lot of them. Over the last probably, I'd say the last 2 years with all the crazy parts, and lack of parts, and we got some really amazing parts in. I'm telling you, got some really bad stuff. I had some bad cams come through. Uh, Cam gears just come off the cam. Lucky enough, didn't damage the engines. The guys that had the engines, I built the engines for. We had 2 different issues with cam gears. Wasn't anything I could do. It wasn't something that you could physically see. The cam gears come off the engine. And these were riveted cams. These were stock cams. So aftermarket camshafts are bolted on. And there's specifics about that too. I'll cover. Stock camshafts are riveted. And I'm not going to get into that right now. So we're going to do this first. But we'll talk about rods, bearings. You guys, like I say, take some notes. You got questions when we get to that point. We'll break here. I'll take a break here probably after we get the crankshaft done, and then we'll take some questions. And then probably by then it'll be about time maybe to lunch. So I'm trying to cover as much as I can. And if anybody has any questions, again, write them down. If I don't know the answer to them, I know somebody that probably does have the answer to them. So, all right. Okay. We'll talk about rods. These are stock Volkswagen, brand new stock Volkswagen rods. Very interesting things. You see the bump on the top. All your aftermarket performance rods do not have the bump on the top. Does anybody know how to orient that rod and the engine on the crankshaft without that bump on the top? Because when you got the bump on the top, that means it goes up. And what I mean it goes up is when I'm putting this engine together, you got the number 3 journal, you got the number 1 journal, you got the number 4 journal, and you got the number 2 journal. Well, 1 and 2 face which side of the engine? As you're looking at the pulley side, it's going to face the right-hand side, passenger side of the engine. So 1 and 2, the bumps need to go up on that side, facing that direction. 3 and 4, the bumps have to go up facing that direction. Okay? Now, I probably lost you already, but it'll another really interesting thing to think about that makes it easy. If you don't have bumps. Bearing tanks. There's 2 bearing tanks for the bearings fit in this rod and the rod cap. Those bearing tanks will always face the floor. So if you install them on this side of the engine, they're going to face the floor. You install them on this side of the engine, they're going to face the floor. It's important because in the past, some of these pistons had offsets. And it's just always been a common thing. It's just always how you've installed rods, period, through the books. Now, not so much. But the thing is, that's important because if you're running stock rods, and you don't want to flip them over. You don't. You want to install bearing tanks down. If you got a performance rod, and I don't have a performance rod laying here, that engine's got performance rods in it. They're not marked. The only way you know is to put the bearing tanks down. So it's important. Bump up, bearing tanks down. It's always the same. Even on a performance rod, the bearing tanks are going to face the floor. Now, granted, you flip that rod over to do it the other direction, it's going to be it's going to be different. So you can get that confused, and that's something that's important. Some people say, well, just make sure. Same thing with the bearing halves. The rod and the cap, they're usually numbered, and you want the numbers to match too as well. Bearing tangs on the caps are going to be on the same side. If you guys can see that, there's a bearing tang here and a bearing tang there, and they're both on the same side of the cap. Cap and the rod, that's the end they belong to. You flip those over, you cause yourself a problem. So your bearing clearance will be right, and you can very well spin a rod or spin a rod bearing. Wrist pins. The wrist pin bushing. That's another thing that there is a specific fit. Thought I had to set pistons out. Let me have to go get them. I always, before I ever assemble these rods and put them on the crankshaft, whatever pistons I'm putting in the engine, I get the wrist pins out and I match them up to the rod, and that wrist pin and that piston, that becomes number 1. And I fit them because sometimes there's a little bit of differences in the tolerances of how these are machined, or it could be the wrist pin. They're usually pretty dead on, pretty spot on. But I have seen instances where one wrist pin would fit rod would tighter. One wrist pin might fit a rod a little looser. And you should be able to put that wrist pin in there with some lubricant and have to just kind of push it. Not beat it through there, but push it with your fingers. You take a lot of your performance engines, V8s, whatever, they have pressed in wrist pins. And they don't. So there's a difference. It's not how these are. If you have to press a wrist pin in one of these, you got something wrong. Your clearance is off. But that's another important thing to do too, is to check that when you get ready to put your engine together, and before you go to all the trouble of getting everything put together, and you get in the case and you're like, oh man, or maybe they sent you the wrong pistons. Those things can happen. That's the thing about building these engines, that you learn something new almost every time you put one of them together. I had a situation where specific style of lifter fit the bores tighter than the stock lifter. So there was a little tolerance issue there. So there's things like that that you just have to pay attention to, and it's the little details. I mean, again, if you love taking stuff apart and spending money and just burning money, that's cool. That's okay. I mean, that's not a problem. But it's frustrating. You put one of them all the way together, you get it in your car, and then it doesn't run. Something's wrong, and you're like, what went wrong? And maybe it was a little too tight a wrist pin on one of the rod ends. So that's something you have to think about. It's pretty important. These rods all come. They're supposed to weigh the same. Okay, and when I say weigh, they're supposed to be the same weight. I think Volkswagen, they can be within 2 grams of each other. Okay, they can be off as much as 2 grams. And I don't have my scale. My scale is captured over here under a computer screen, but I didn't get it out. I usually weigh these. I haven't weighed these, but and all the times I've weighed rods, brand new rods, even stock rods, these rods all weigh the same. And it's interesting because I do performance engines, and we might use a set of rods. Somebody will specify they want German stock rods. They're great rods. But I've got probably maybe 100 sets of German stock rods that I've rebuilt, put new bushings in them, done that kind of stuff. I only use them if somebody specifies they want a German rod and they don't have a problem to use rod that's been remanufactured. And I do remanufacture the rods. It takes a lot of grinding. If you've got one that's more than 3 grams, 4 grams off, it takes a lot of grinding to take that stuff off those rods. I'm telling you. Balancing engines, that's something else you get into. I don't balance my components. I've got 2 different guys that I send my stuff out to. They've got the equipment to balance. I can send them a crankshaft, rods, flywheel, pressure plate, clutch, all of it assembled. They balance it all together. It goes in the engine. It's wonderful. Everybody says, well, why would you want to balance an engine? For the most part, Volkswagen didn't really balance them. I mean, they build the crankshaft. They balance the crankshaft. They make sure the rods weigh the same, those kind of things. If you're building a high-performance engine, it's suggested, it's recommended that you balance the assemblies. Again, a lot of people will spend a large amount of money on a performance engine, and all they're going to do is drive it to car shows. It's fine. That's okay. Where it becomes very important is if you're going to turn an engine at 8 grand, 8,000 RPM, almost all the time. I got a sand car up there that when it's in the sand, it sees idle, or it's probably 75 to 8,000 RPM, almost all the time. If that rotating assembly is not balanced in that engine, it's going to beat the main bearing saddles out. I got a crankshaft over here right now. It's assembled. It come out of an engine that it absolutely beat the main bearing saddles completely out of the engine. It wasn't balanced. I didn't put the engine together. I know who did, and it's unfortunate. But he brought the engine to me. It's supposedly a fairly new build. I got in there and found the dowel pins for the bearings. I could take my finger and wiggle them in the case. And I said, well, how many hours do you get on this thing? He said, maybe about 100 hours, maybe at the most. And it was in a sand car. So anything that goes in a sand car, it's going to get abused. That engine in that sand car has been abused. That's just, if they're not balanced, they're not going to stay together. And it's an air-cooled engine. You run hot, you're going to tear stuff up. There's just little things that once it gets out of kilter, it's going south quick. And then if you trash the case, you trash the case. That's probably the most expensive component of this entire engine build is the case. These aluminum cases are pretty robust. Magnesium, not so much. They've built these and designed these for a little bit more of a load. Of course, granted, they weigh they're 20 pounds heavier. So you got these old school guys, these guys that are all worried about weight. I still run a mag case in my sand car, so I wouldn't run an aluminum case. I don't want to add 20 pounds of weight to the car. So whether that really makes a difference, I don't know. But in my mind, it does. So, but anyway, that's the other important thing about balancing any performance engine. I've had people come and I build them a stock engine. They say, I want everything balanced. Okay, sure, we can do that. It adds about $250 to the cost of the build just to do the balance. So it's a good thing. It's like blueprinting an engine. It's very similar to when you hear people say balance and blueprint an engine. When you blueprint an engine, you take the various measurements, you set your cam play. There's all kinds of things that go on with these engines. And I can get into a whole ton of stuff and drag a whole bunch of specialty measurement tools out and all that. I'm not going to do that. Even with some pistons and cylinders. Pistons and cylinders they manufacture today are pretty darn good. They don't. There's two specific types of pistons and cylinders I will buy. I'll buy AA and I'll buy Mauch. Those are the only two. They're actually, I still think, Wiseco makes pistons too. It's funny. Wiseco only makes the pistons. They won't sell you cylinders. They won't sell you. They make. I can't remember if they. No, I don't think they even give you rings. They just sell you the pistons. The reason for that. They want you to fit those pistons to the cylinders you're going to put in. They want you to correct and make sure that your ring gaps are right. All those things. And they're expensive pistons. So, again, it's one of those deals that you get into building one of these. You got to know what you're doing. You can buy the Go Fast cool stuff. But there's reasons why they do that. I've got a motor sitting over there, engine sitting over there on the stand. That to build that engine today would be probably an $18,000 to $19,000 engine. It sits there telling me, Mark, when are you going to get me running? When are you going to get me running? I got plans for it. I've got a Pro Stock drag car, VW drag car, and that's probably going to go. And that's going to be another one of those engines that I'm going to put it together, and it's my plan to abuse it. I'm going to abuse it. I'm going to abuse the transaxle in that car. My wife said, you'll go to the drag races if and when that ever happens. Get that car on the road, get it going. You know what's going to happen? Everybody's going to want you building the transaxle. The transaxle doesn't break. And I said, well, I may break it. I may have to try to break it. So I built the transaxle in this sand car about 12 years ago. At the time I built the engine, I wasn't versed in that one and didn't have the tools to build a transaxle for it back in the 70s. So I bought a transaxle. It served me well for a lot of years. And then about 12 years ago, 14 years ago, I pulled the transaxle out of it and I rebuilt the transaxle. I spent $5,000 on components for that transaxle. And probably, 60, 80 hours worth of labor at the scene. And we put that thing together. We went to Little Sahara. We thrashed it. We brought it back to the shop. I told my son, I said, go out and drain the gear lube out of it. So he goes out there and drains the gear lube out of the transaxle. I says, Dad, there's no shavings in this gear lube. There's a reason why. Every gear, every surface in that transaxle, I oil stoned every gear and took all the sharp edges off every gear so there was no breakage. So maybe I'm on to something, maybe I'm not. I do know guys that build them, and they say that to do that, to do the performance transaxles, there's a lot of that stuff. These Albans and these Mendiellas and stuff like that. That's why they're $15,000 transaxles. They put them behind, 1,000 horsepower Chevrolet engines, that kind of crazy stuff that they do with them. And it takes that. A transaxle, split, swing axle, whatever, they are not designed for horsepower. And there are weak points in those transaxles that you get to a point, you're good to this horsepower, and that's it. If you go past that, you're going to need a transaxle. Anyway, a little tidbit on transaxle. Okay. Talked about rods, balanced and rotating assemblies. It's a good idea. For a stock engine, I don't recommend it. Most of the stuff, every set of rods that I build and put into an engine, I weigh them, make sure they're right. I have weighed, I don't know, 100 sets of rods. I'm not fanning any of the off. They're dead on. Every one of them weigh the same. There's not an issue with that in most instances. But it's important to fit piston wrist pins to your rods. Pull your pistons out. The first one you pull out of the box. Of course, you guys also know, and I'll get a set of. I've got a set of pistons. Say these are performance pistons, so these are a totally different beast. That's what you call a slipper skirt piston. You see how short it is from here to there? The reason for that, well, the crankshaft in that engine runs so close to that piston, they have to chop part of the bottom of the piston off to make it work. And again, that's fitting wrist pins to rods. That's what I'm talking about. This little guy here, I take them out, I fit them to the rod, whichever cylinder I'm looking at. And of course, this one's got, you can see number one there. And that measurement is 47 thousandths. There's also an arrow on the top of these pistons. Anybody know which direction the arrow faces? Which way does it face?
The right way.
Towards the flywheel. Everything on these engines is towards the flywheel, the front of the engine. So that one's got some numbers on it. That says .047. That's 47 thousandths of deck clearance on this piston in the number one hole. Okay. That's on there for a reason. So, and that engine I've got shims. That's the other thing that to get you have to on these stroker motors, you got to have at least 60. I like to see 60 thousandths clearance between the rotating components. Anything gets outside of anything gets outside of 40 thousandths, there's something really wrong with it. It shouldn't do that much. But again, when you put these together for building a stroker motor, and especially with 82 and 84 stroke cranks, you better make sure this stuff clears. Because when you fire it up and run it, it ain't gonna take you just a minute or two, and it'll make its own clearance. It'll make the clearance that it needs. But yeah, that's a little bit about pistons and wrist pins. Like I say, I fit the wrist pins to the rods, whichever cylinder I number them. These are all numbered. This is number one cylinder on that engine there. So, and cylinders, just a standard cylinder. They make different ones. They've got a thin wall piston or a thin wall cylinder and a thick wall cylinder. There's been a lot of debate and talk about thick walls, thin walls, and whether they're gonna last longer or they're more prone to overheating. Anything that's thinner is gonna have an issue if you overheat it. It doesn't have the material there to absorb the heat, dissipate the heat. It's less material. So you don't see too much of it anymore. They've got slip-in kits. I've got a 40 horse over there for this bug. It's got 87 slip-ins. The case is not in the machine. They're thin wall cylinders. Do I plan on overheating this engine or driving it like crazy? No, not so there's some points to that you just have to decide. That saves you from machining the case and go a little bit bigger on the piston size. It's really negligible how much you're gaining from that from 85 to 87. You're not gaining much, a little bit, tiny bit. You're going to get more from a low-end performance camshaft and cylinder heads. Those two have to be together. You can take a stock 1600 and put a nice set of heads and a cam in it, and then run ratio rocker arms. Ratio rocker arms are crazy what they'll do to a stock engine. Because what they do is they open the valves up further and open them up. Not really any longer, but they just open them up further. So there's a little difference in how much they open close. So that's the engine breathing. But you're always limited to cylinder head design, rocker arms. Those things are two big things when it comes to doing performance engine. But a lot of people say, I want this 500 foot cam, and I don't know. That's great. It's wonderful. It's cool. Do you need that? I can build you a 1600 that'll run circles around a lot of them all day long. and you don't have any problems out of it. You don't have any issues. What you end up getting into 9 times out of 10, and I haven't had to do it to the stock 1600s. Anything beyond 1600, you have to do rocker arm geometry. I checked the rocker arm geometry on some of the 1600s because these cases are all different. And they've always been within spec. I haven't had custom cut push rods. That's another thing you get into. Rocker arm geometry is a whole nother class. I could spend 4 hours showing you how to set up rocker arm geometry on an engine. It's just that detailed and precise. And I do. I usually spend about 2 hours cutting push rods for any of these performance engines. That's the next step on this engine that I'm going to do. Is it will be I'll set the rocker arm geometry up, and that'll be cutting push rods, getting those measured, checking those things. I dial in the cam. And there's a whole lot of things that I look at when I get ready to do that. The shortest, easiest, simple way to explain that is you want those push rods to be adjusted to a length where you're at half width on your camshaft. And that can be whatever. It could be half of 500 lift, which would be 250, and there's different numbers. It's going to be half lift, and that's going to be on a dial indicator, half lift, however many thousandths that is. Lock that crankshaft down, you make your measurements, and then when you set your rocker arms, you set your rocker arms to where they're perfectly perpendicular, valve stem, and that means they're not this way or that way, but they're level, halfway. And that means they're basically halfway through the travel of that valve. So it's important. You have to lock crankshafts down. You got to do that stuff in order to hold those things in place. Because you can do 6,000, and that's a ton of difference. A whole lot of difference on that push rod. And 6,000, 10,000 is going to be crazy amount of difference on your lifting. So I've seen a lot of engines that have had the engines come in that somebody cut push rods for them, or they didn't cut push rods. They put stock push rods in them, or high lift cam, and they said, "Well, the engine never really ran like I thought it should." And I said, "Well, let's look at the rocker arm geometry." And I cut them set push rods, put it back together, and they drive the car and they're like, "What'd you do to this car?" I just put the right wing push rod in the car. It doesn't even have this. And that's just it. That's what you get into with a lot of that stuff. Is those kind of things. So it's important. There's a lot of variables, a lot of little tiny idiosyncrasies they're involved in building one of these engines. And it's not, I'm not going to say it's easy. It's not. It's not for the faint of heart. I mean, you're going to tear up stuff. If you're wanting to learn, you're wanting to build them, you're going to mess up some stuff. You're just going to, unless you've done enough of it. And that's just it. Trial and error. There's a lot of it's trial and error. A lot of it's just actual knowledge. But, and just from doing it too. And no two of them ever go together. I mean, that's the truth. I've got a book. I write down all my rocker arm geometry measurements. I write down for every engine build I do. I've got all the crankshaft in-play measurements. Something else I also do in these engines when I build them. And that's for me. I'm getting older, and I don't always remember. I have a series of things that I do as I build one of these engines and put one together. And I always mark all my torque bolts. You see, there's a little dot of red paint on every bolt that I put in. So when I look over there, I went to bed, had to go see grandma, whatever. I've done all these things, and I forgot all about this engine. Come back here, did I remember that I torqued that? Well, it's got red paint on it. I must have. I don't put the paint on it. So that's just a visual indicator for me. It helps me remember whether I did something that I completed that step. It's important. It's just a little tiny detail that's really good. Those die-cast paint markers is what I use. Right here. That's what I use on the red's easy to see. I even go as far when I torque rods. I put a little paint dot on the rods. And I know everything's done. Everything's done. I can visually look at that engine go, I didn't forget that. And same thing with timing. I do the same thing with cam gears. Cam gears and crank gears, there's two dots. There's 2 dots on that. Those 2 dots correspond with a single dot on the cam gear. Okay. Now, some of these cam gears, you got to watch them. Because there was a point in time there, I don't know why they did it. I think it was just a batch of them that they had that they put 2 timing marks on. Well, if you're not paying attention, you find, oh, there's a timing mark. You can't get the engine right. And when you start, you're like, wait a minute. And I'm not saying that from experience because it hadn't happened, but I've just noticed that I've got some cam gears in where it had some different time marks on it. What you can always remember, you see where that mark's at? See where the hole's at? That's it. The other thing is too about putting this together on a camshaft. And I'm going to cover that in a minute. I don't want to get off on that subject right yet. But there's also the way the cam gear goes on the camshaft, and it can go on there 3 possible ways. So you got a 1 in 3 chance of getting it right. But there's the slot, the oil pump slot, always faces this bolt straight up down. The slot is just like this. You put it on the cam, it's right. So straight down like that. And I'll show you when we put it together. Anyway, so covered cam gears, covered balancing. I don't want to get off on any type, kind of get tangled up on some tangents, but wrist pins. Okay. Oh, okay. Now what I want to do, we're going to move forward. We've got bearings marked and stuff. We're going to move over here to the crankshaft. This is a 69 millimeter crankshaft stock. It's not counterweighted. There's a difference in a counterweighted and non-counterweighted crankshaft. Counterweighted crankshaft is somewhat balanced. Factory crankshafts, same thing, they're balanced to a point. Counterweighted crankshafts, they basically streamline a little bit, so they turn a little smoother, a little faster, a little better. It's about the easiest way to explain that. These cranks are cross-drilled, this, that, and the other. You can get a chrome moly crankshaft. You can get a cast crankshaft. When you get into the higher end crankshafts, once you leave 69 and go to 74, 78s, 82s, 84s, you can go past that. You're going to have, it's going to all be chrome moly. Most of those, the better quality ones will be chrome moly crankshafts, and they're very expensive. They go up in price exponentially according to what you're asking for and what you want. And then they've got wedge mated crankshafts. It's a whole nother beast of all of its own. And then again, wedge mated crankshafts, you get in a situation where you're doing a lot of drag racing, a lot of really hard launches with the car. Wedge mated crankshaft is probably the best way to go because not only it's not dowel pinned, it's got bolts and it's wedged onto the flywheel and there are bolts that hold it. Flywheel, not dowel pins. Dowel pins in one of these crankshafts. Stock crankshaft has 4 dowel pins, and I don't have the dowel pins on in this one, but we break for lunch and just still get all of that. But there's 4 dowel pin holes. Performance crankshafts usually have 8. I've got jigs. I can take the stock crankshaft and I can take it over to the vertical mill and I can do an 8 dowel crankshaft. By the time I set my machine up and drill those dowel pin holes, I've got enough time in just to do a lot of crankshaft that's already been done. So that's usually what I do. Unless I've got somebody that's got specific, they want to keep something all stock, whatever the case may be. Most instances, you can't find an 8 dowel stock flywheel. They're all locked. Running a Lighten flywheel, there's pluses and minuses to that. The plus is, with a Lighten flywheel, you're going to get a faster RPM rise quicker. Engine's going to come up to RPM quicker. Downfall to a Lighten crankshaft is, say you're going to run it in a bus. Split one bus, whatever. That inertia, that mass from that 13, 14 pound flywheel, that's going away. So that initial being able to push that bus is going to change. Whether it's going to change it that much, it's probably negligible. I can get in a vehicle that's got a Lighten flywheel on and tell you it's got a Lighten flywheel. Just the characteristics of how it works. I usually like to do, if I'm building a performance street engine, I like to try to do a heavier flywheel. They do work with a lot better inertia. It's like anything else. You lighten it up and you lose some of that rotating mass. And that rotating mass, when you lose that weight, you're going to lose some other things too. You're going to gain some things, but you're going to lose some things. So running a Lighten flywheel, that's a personal thing. I mean, if you want most counterweight crankshafts, stock 69 millimeter counterweight crankshaft comes 8 dowel. So you have two options. You either hunt up a 4 dowel flywheel and have it drilled for 8 dowels, or you buy a Lyden flywheel that's 8 dowel, and that's usually how they come. There's no in between. So you have to make that. And I've done both. I've done standard flywheels on the counterweighted crankshaft, and I've done Lyden flywheels. It's all in personal preference. You do lose some and gain some with both avenues or aspects of it. Covered rods. We're talking about crankshafts. I think I've covered pretty much everything on the crankshafts that we need to cover. Again, stroker cranks. Everybody asks, well, what's the biggest you can go without having to clearance a case? You're going to have to clearance a case. I mean, you might be able to get away with a 74 in a stock case. It's going to be close. And to clearance one of these cases, it's a whole nother process. I mean, it's a lot. I don't have that in the part. I don't have a case here that's got a bubble top, but I do have cases that you can see that they clearance them from the factory, and there's a lot removed for those crankshafts running with rods running. And then, of course, you take the performance rods, the caps on those performance rods are just about a third of what these are. So it's almost a smooth edge all around. There's no sharp edges, so it's got the ability to handle clearance in a stock rod. Lots of stuff. I mean, you get into that. Again, great little engines, superb engines in their stock form. They're wonderful. Performance engines, they're wonderful. But you're going to give some things up when you start hot rodding. And I'll talk about some of the other stuff too, because I want to try to cover the things and go through the process. I'm going to try to build a crankshaft here. I've got to get a few pieces put together here right quick, but we'll do that. Get those caps broke loose, and do not have any dowel pins in this, so I'll have to gather up some dowel pins for that. I've got some over there. But other than that, what time are we at now? About 10 o'clock? 10 o'clock?
10.
10?
5 to 10. Yeah.
Okay. Tell you what, let's go ahead and take about a 5-minute break, and I'm going to gather a few more pieces up, kind of get them staged over here, and then come back in. Come back in, whatever you guys want to hang out here is fine. If you want to go get a drink, whatever, that's okay. Get up and stretch, that's good. And I'm going to go ahead and try to get some pieces put together here right quick so we can try to build this crankshaft.
I like to use a whistle.
Yeah, right around the corner. You can go right around the corner there. Yeah. And there's restrooms outside too. I can try. I can try to do that. We were having a little problem. Sounding better. Can you hear it better now? That might have something to do with that long shirt. So,
This sounds good.
okay.
Yeah, I'm not sure. Oh yeah.
That's not like the old days. You couldn't hardly find most of them.
Yeah, I love this one. Yeah.
You know, one at home. It says, "Let's see." That's the first place I saw. It was 03 with the hospitals. First time. Yeah. And yeah, it was over here on the side of the road. Yeah, we found it for sale. It was like right after the West, I got married.
You know, you sit there in your driveway and just for some reason I
picture of these marks here.
That's the problem. You go out there and let it run.
Mark, you got a mop or something for a spill?
I
Well,
don't know.
I'm in the market.
Probably, I don't know if I've got one in here or not.
Use some of these towels, or you got some?
Yeah, those blue towels are fine. Yeah, that or yeah, use those. That'd be okay. That'd be all right. It's a shop for it. It's not a hurry.
Wherever I want to pick up. That was my, because I know it was, you're right. Y'all drove 1,400 miles up into the Rockies. I'm like, no, dude, I'm not going to do that. I just want to hang out with them. Drive 50 miles, park the trailer at Walmart, and drive it over there. And over there at Creek Springs, it's so much of this. And we've been up there a couple of times. Oh, yeah. Yeah. Oh, and I bet it's beautiful. Have you ever been there in November? Okay. When the leaves are all changing, because they always talk about Tallahassee Drive, how beautiful Tallahassee Drive is. We went, our anniversary was in November.
Too many Volkswagens when you start piling junk on top of them.
Yep, you get too many, that's what happens.
Every time you look somewhere, and then we came home down to Tallahassee.
So when you're checking the play, like if you're buying a used engine, is
Yep.
those dowel pins? Is that usually what's
No, it's
loose
just
on
that,
them when you're
it's that,
when
it's that
fluid?
bearing. That bearing walks around in the case and beats that case up, and that's why they end up going oversized on the wall. Or they
You
board
need
the case.
water or something. You need
Yeah,
a pop or
I think
coffee.
I've got.
one.
I think I've got some water over there somewhere. Yeah, I think I've got some over there.
And so if an engine doesn't turn over, is it due to the fact that those are crushed?
Could be. Could very well be. It's a
an
brand new
engine,
bill.
if it's been setting for a long time, what would cause it not to turn? What would cause the flywheel not to turn at all?
Just piston stuck. And
Piston stuck in it.
Rust. Rust built up.
Can you pour Marvel Miracle Oil in that?
You
Let it
could.
set for a while.
You
Is that,
could. You could certainly give it a shot. That's what you could do it.
Sometimes that's work with motorcycle.
Is it?
That one
Yeah.
Honda, that one I got, I said for years, also rated stuff.
Did you put it in there? And
Well, and turned right
It did,
over.
okay.
And it ended up running great. Didn't have to open up the engine oil.
We went to New Year. Yeah.
Oh, no.
Yeah. How to keep your boat running. John, and you're. Yeah, I've got that.
You said, like,
Yeah.
yeah.
We went to Anna Marie Island, Florida, vacation for 5 days. Just me and my wife. All we did was fish like freezing. I had my umbrella. I rebuilt my bus. And you guys was free. Yeah.
Yeah. So, yeah, that'll 57 series of pistons were seasoned in. I took the plan and I left the U with a better bracket on put screws on it. Get force it down and kind of push the piston and put it out. Yeah, but it worked. Yeah, I said I just watched it on YouTube. there's lots of different ways to skin a cat, so to speak. But it's kind of fun. But the main thing, one thing I started playing with motorcycles is they got a whole lot less room than cars. Get quite a few of them in smaller space cars. So they just sort of stack them or something like this. So, but now I feel like my capacity for motorcycles. And I didn't get a boat for it, but I looked at that. My neighbor, yeah, it's it's funny you should mention that because it's the family that lives in the house is not there. They're very old. They'll be there. And somebody was out helping me hold on my motorcycle and taking it on my show and do something. Mike Farnham, and he said, "I'm surprised you hadn't tried it." And I never even thought of it. And then all of a sudden, my wheels started turning. Well, a year or so ago, I've been bowling all around because I have something to go there. Getting on ball. I've been bowling. I think I put a canyon from last one. Last and I said, "Hey," I said, "You got good camps." I mean, but the property line hasn't been this week and I have to carry it back. And I have to build it. I said, "Well, there's some people got some cars for that." I mean, that's all I can know. Maybe it works out now too. I don't think it's a ghost chick. I said, "Good." Because then I would have all kinds of fruit. It would be awesome. I could make a paint booth out there. I could do all kinds of, yeah. But because I get my biggest figures, we're going to set that place. I think they put a marijuana grow shop out there or something. That's what happened to a friend of mine. She had a chance to buy some place, and we had a chance to buy some place, and they got a marijuana grow shop. I go, so I'm like, we're saying, obviously the property worth a lot more with that, with it. Who bought the front and put the wall in that, but if I bought it, yeah, I don't want precious people, but I'm gonna mention. Well, he's Italian. I'm gonna come over. Just to come over, yeah. He wants to come over some guy to so I come down to Italian trip because his family come from Italy here, so it's a go over there.
Yes.
That's what I'm looking for,
and there's somebody else has already been with it. You know what I mean? It's like really further looking for a place that
a lot of you look at places. That's a big building. Mostly.
Yeah, it does. I've heard of that. Yeah, I trust that.
well, you were
Right.
stores and stuff. And
Oh,
Right.
that sounds even better. Go back.
never see it.
That would be terrible.
Yeah, yeah, I'm pretty bad.
That place of mine is kind of isolated. You gotta be, you don't just drive with it.
Never really noticed it. I've only noticed it because we
Yeah.
had a car that day.
A little bit louder. I was messing
Well,
with it earlier.
on that row of cedar trees there, you kind of walk, you can't see it. Right. I bought that there, I knew we were gonna build there 2 years.
Yeah, fantastic. So turn up that. Yeah, turn the light up. Right, so. I'll tell you what to do. Is that better? Now better? Yes. I try not to talk real loud, or I can get real loud, and now it's probably too loud. So, is that better? No feedback after it. All right.
I'll probably give them. But I've run out of space.
Was concerned about parts cost of a project like this than about the tools cost.
Yeah, yeah.
The parts all need it.
Well, that's where I get to cheat. I teach out at the VOTEC.
Ah, nice.
So, you know,
What
what do you teach? Aircraft maintenance.
Oh, cool.
Yeah. So that's what I tell people. I was like,
everyone wants a shop like this in their backyard. And I do too, but it's like I let the state of Oklahoma buy me a $10 million shop.
Yeah, exactly.
I've got access to things I could never afford.
Things
I
I know how to
just
do.
collected stuff a little bit at a time.
Yeah, over
my,
the
my
years.
most favorite.
Yeah.
One of the neatest things I've got recently is that vertical mill.
Yeah.
I've spent money on. I bought some stuff at auction too. I got a 14-inch rotary table back there on the mill. That's
Oh, wow.
like a $2,000 rotary table. I give $250 for.
Nice.
And it stays on the table because it weighs almost 300 pounds.
Right.
You know, pinch fingers, you're not careful. So I need to put me a chain and stuff above it before I mix it. I got a ton of jigs and stuff for putting these cases on there. It takes all that together to do machine work. You got the right jigs and equipment to jig them up. You can put them on the bed, but I've even got the jigs that you mount it to, and it puts them in the right position. So, yeah.
That was a deciding factor with our house. We walked through our house. I walked into the backyard and saw an old dairy barn on my property, and I turned around, and looked my wife in the face, and said, "Sign the papers.
It's ours. Yep.
I'm home. I've dreamed of